Here's another example of graphing a rational function, x squared minus x minus 6 all over x squared minus 16. Now, when you get a function like this, one of the first things you might want to do is see if the numerator and denominator are factorable. And in this case, they are. The numerator is x plus 2 over x minus 3, and the denominator is x minus 4 times x plus 4. That's just a difference of perfect squares. So with that in hand, we can start as usual. Let's find the y-intercept, f of 0, and it's easy to do from that right side in the green box. It's 2 times negative 3 over negative 4 times positive 4. So what is that? Negative 6 over negative 16, which reduces to negative, it's positive 3/8. So we can plot that. If we call that 1, then this is a half, and here's about positive 3/8 there. So there's our y-intercept more or less. Remember, this is just a sketch. Okay, let's find the zeros, and we already factored the numerator. Remember, the zeros are the zeros of the numerator. So our zeros are x is equal to negative 2 and x is equal to 3. So we know that this function passes through the x-axis, straight through, all the way through, at x equals negative 2 and x equals plus 3. Those are single roots of this function. And it's worth remembering that these are the only two places where this function crosses the x-axis. Now, the vertical asymptotes are found by finding the zeros of the denominator, and we factored the denominator at the beginning, so that's x minus 4 times x plus 4. So the vertical asymptotes are at x is equal to plus or minus 4. So we can just sketch those in. At minus 4 and plus 4, we have vertical asymptotes. Next, we find the horizontal asymptote by asking what's the limit of this function as x goes to plus or minus infinity. And to do that, one way to think about it is, well, at very large x, the minus 6 and the minus 16 don't really matter. So this is going to be approximately equal to x squared minus x over x squared, and that's because the minus 6 and the minus 16 don't really matter when x is very large. So if we take an x out of everything, we get x minus 1 over x, and then the negative 1 really doesn't matter either for large x, so this is really just x over x, which goes to 1. So our horizontal asymptote is going to be at y equals 1, so we can sketch that in. Now, there's a very important thing here about horizontal asymptotes that we need to remember. This function is allowed to cross the horizontal asymptote. This particular one won't, but it could. A function can cross the horizontal asymptote, because remember, the question you're asking when you find the horizontal asymptote is, what does this function do when x is very large in the negative or positive direction? And you're not asking about somewhere in the middle. Now for this function, the only sketch of the graph in the middle here that makes any sense is to go from 3/8 right down through those roots. Remember, the function has to pass through the x-axis there, and then it has to behave asymptotically at these two vertical asymptotes. So this is consistent with that information. Now to figure out the behavior of this graph to the left of negative 4 and to the right of x equals 4, we don't really need to calculate any special points. It really has to live up in these two corners, the upper left and the lower right, because it just can't intersect the x-axis anymore, and it eventually has to approach this horizontal asymptote on the left or right. And then of course it has to behave asymptotically at those vertical asymptotes too. So I think this has got it. And here's the calculated graph, and you can see that we got it pretty good. Our sketch looks okay. Here are your horizontal asymptotes. Here's y equals 1 approximately, and so that looks pretty good.